All right, so let's talk about part 5. So let me kind of give you the visual of what's happening here. So in the bottom left corner, by the way, the days of symmetry are gone. In the bottom left corner, you're going to put 2 negative charges right on top of each other. Okay? 1 meter over, you're going to put 3 positive charges. Okay? Stacked. So you're going to have 3 positive charges here. Then you're going to have to do a little bit of algebra and figure out exactly where to put a single positive charge so that what you have is an equilateral triangle. Okay? So what do you know about equilateral triangles?
All the sides.
All the sides are the same. So obviously the bottom side isn't the issue because that's just along your x-axis. That's just 1 meter. So, but then you got to figure out, oh, how am I going to get this thing 1 meter apart? Okay? Now, here's what you're after. Here's what you're after. What you're going to try and find is determine the magnitude and the direction of the force on the single positive charge. Okay? So, let's kind of back this up. So you're going to have 2 negative charges down here. You're going to have 3 positive charges here, and then you're going to have a single positive charge here. Now, we're not trying to find the field. We're actually trying to find the force. And we can find the force because of the fact that we know what the charges are. Now, before you get too far down this road, okay, let me give you a word of advice on how to start this problem. You're trying to find the net force acting on that positive charge, right? So, you have the 2 negative charges and you have a single positive charge, and you know conveniently that that's separated by a distance of 1 meter, okay? So what's that positive charge going to feel from those 2 negative charges? It's going to feel an attractive force this way. Okay, and you can calculate that because you know what the 2 charges are and you know the distance between them. Now, so that's from this interaction with 2 negative charges. What's it going to feel from those 3 positive charges? It's going to feel a push this way. Okay? So here's what you've got. You've got a push going up like this. You've got a pull going down like that. So, what do you think you're going to have to do with those forces?
Components.
You got to find the x and y components of each one. Are they going to be the same?
No.
None of them are the same. Why?
Different charges.
Yeah, you have different charges. Okay? None of these are the same. So there's a whole bunch of steps that you need to do to this. You need to find the force going this way. You need to find the force going this way. Then once you get those, find the x components and the y components. Then you're going to draw a new triangle with the sum of the x and y components and the resulting angle. Good luck, you're on your own.
Oh dear.
Wait, what's the new triangle?
Negative.
So let me give you a hint. I would set up a chart of x and y components of like here's the 2 negative charges and here's from the 3 positive charges. And then I'd find the sum of those. That's what I would do.
Shut up, Michael.
Okay, good luck.
Shut
All right,
up,
Mara.
Michael.
Does that look equal right?
Shut up, Michael.